What happens when science turns the microscope on itself? Imagine researchers using the tools of science to analyze how science actually works, from experiments to discoveries and even failures. This fascinating, mind-bending approach is revealing hidden patterns, surprising biases, and insights we've never seen before. But can science truly understand its own process objectively? In this video, we dive into the strange and captivating world of science studying science. What might it uncover, and will it change everything we know? The scientific method is a systematic and logical approach that scientists use to investigate phenomena, acquire new knowledge, or correct and integrate previous knowledge. It begins with observation, where a person notices something intriguing in the natural world. This leads to the formation of a question. Based on this question, a hypothesis is developed, essentially a testable prediction or educated guess about what might be happening. Once a hypothesis is formed, scientists design and carry out experiments to test it. This involves careful planning to control variables and ensure that results are valid and reproducible. During the experimentation phase, data is collected meticulously. Afterward, the data is analyzed to determine whether it supports or contradicts the hypothesis. If the results support the hypothesis, it may be further tested or developed into a broader theory. If the hypothesis is not supported, it's revised or discarded, and new hypotheses may be formed. This is a cyclical process, meaning that each conclusion can lead to new questions and further investigation. A key strength of the scientific method is its emphasis on objectivity and evidence-based reasoning. It allows scientists to minimize bias, remain open to new findings, and build a more accurate understanding of the world. This method is fundamental across all branches of science, from biology and chemistry to psychology and physics, and it underpins nearly every scientific discovery and technological advancement in our modern world. Observation and experiment are two fundamental components of the scientific process. Observation involves using the senses or tools to gather information about the world. It's the starting point for most scientific inquiry. Scientists notice patterns, behaviors, or phenomena that raise questions. Observations can be qualitative, like noting the color of a flame, or quantitative, such as measuring temperature or time. Once a question is formed from an observation, an experiment is designed to test a hypothesis related to that question. An experiment is a controlled procedure carried out to discover, demonstrate, or test a fact or theory. It includes variables, factors that can be changed or measured, and it aims to produce data that can confirm or challenge the hypothesis. Observation continues during the experiment to record results and detect changes. Together, observation and experiment provide the evidence scientists need to draw conclusions and understand how things work. They are essential tools for turning curiosity into knowledge. Peer review and publication are essential steps in the scientific process that help ensure the accuracy, quality, and credibility of research. Once scientists complete their study and analyze their results, they write a detailed report or paper describing their methods, findings, and conclusions. Before this work can be published in a scientific journal, it undergoes peer review. During peer review, experts in the same field evaluate the research to check for sound methodology, valid data, logical conclusions, and originality. They may suggest revisions, request clarification, or even reject the paper if it doesn't meet scientific standards. This process helps catch errors, prevent bias, and maintain the integrity of science. Once the paper passes peer review and is published, it becomes part of the scientific record. Other researchers can then study it, build on it, or challenge it with new evidence. Peer review and publication play a crucial role in advancing knowledge and maintaining trust in scientific discoveries. One potential danger of peer review is the risk of it becoming a filter that keeps official science in line with a particular theoretical perspective. This can occur even without deliberate intent if the scientists doing the reviews hold to that particular theoretical perspective. The risk is even worse, however, of it occurring by deliberate intent. Furthermore, it needs to be noted that peer review is not in and of itself part of the scientific method. Whether or not a concept is scientific should not be based on whether or not it is passed peer review. Peer review is simply the doorway to publication in a scientific journal. It is not a defining feature of science itself. This is particularly true with regards to whether or not a paper was published in an establishment journal. Observational science, also known as operational science, is the process of observing how the universe works. This is the type of science where the scientific method works at its best, and where philosophical roadblocks are easiest to overcome. This is because such sciences, which generally include physics, chemistry, the functionality of biological systems, geological processes, and a lot more, take place in the present where they can be observed. It is within observational science where experiments can be controlled. Now, when observing nature, you cannot have the control of an experiment. The observation is still what the observation is, and it will either agree or disagree with theory. Science is at its best when as many variables as possible can be controlled. This is why experimentation is such a critical part of science. The more variables you can eliminate from an experiment or even an observation, the less opportunities there is for other possible causes to interfere with the results. For example, if you have two possible causes that can produce the same results, it might literally be impossible to tell one from the other. You want to eliminate as many variables and as many possibilities as you can. This is why direct observation is as important as it is. The further you get from direct observation, the bigger the opportunity for alternative possibilities to be viable becomes. This is particularly true when you are dealing with difficulties due to distance, size, and time. Historical science refers to the scientific exploration of past events, phenomena, and conditions based on evidence and analytical reasoning. Unlike experimental sciences, which rely on reproducible experiments and direct observations, historical science is retrospective. It seeks to construct narratives and explanations from traces left behind, be they artifacts, fossils, documents, or geological formations. This field intersects with numerous disciplines, including archaeology, paleontology, geology, anthropology, and history itself. Together, these disciplines form a cohesive framework for interpreting the past and understanding the mechanisms of change over time. One of the major difficulties of historical science is the fact that time has a tendency to destroy evidence. A perfect example of this comes from the forensic science of crimes. The problem faced in any case is that the longer it goes unsolved, the less likely it is to get solved. This is because evidence can quickly be degraded, as well as being destroyed either accidentally or deliberately by other means. Within forensic science, there is at least the advantage of working close enough to the present that the methodology and assumptions can easily be tested. However, when dealing with the distant past, it becomes harder and harder to actually test your methodology and assumptions that you are working on. In archaeology, for example, if you discover a set of ruins with no clue as to who lived there, whether or not is attributed to a nearby group would depend upon what you thought about the history of that group. If you thought that they were always a primitive tribe, then you would be unlikely to attribute the ruin to them, but if you think they had a more advanced civilization in the past, you would be more likely to attribute it to them. Paleontology is the historical science dealing with fossils. Unfortunately, because of the relative rarity of fossils, much of the evidence that would have once existed if universal common descent evolution were true is missing. The claim is often made that 99% of all species are extinct. However, when you compare species known only through fossils with those that are known to be living, it turns out that 97% of all species are actually living right now. That means that the only evidence for the 99% extinct claim is the presupposition of universal common descent. It also means that the concept of universal common descent is based largely on a science where 99% of the evidence that should be there is missing. This doesn't seem to bother them, as it would in any operational form of science. However, with such historical sciences, the excuse is that fossilization is rare and a lot of the fossils have been destroyed. It is, however, convenient that the very fossils that are hypothetically missing are the ones that would really put universal common descent to the test. Methodological naturalism is a philosophical framework that is used in the scientific method, guiding researchers to seek natural explanations for phenomena in the physical world. It is distinct from metaphysical naturalism, which asserts that the natural world is all that exists. Instead, methodological naturalism is an approach that limits scientific inquiry to empirical and observable phenomena, fostering the exploration of the universe through evidence-based practices. By focusing on what can be tested, replicated, and falsified, methodological naturalism provides the foundation for the objectivity and reliability of scientific findings. This approach is fine as long as you are working with operational science where you are trying to explain how the universe works. After all, by definition, the regular function of the universe is going to be natural phenomenon. However, it falls apart when you start trying to study the past. This is because if anything other than natural events occurred and you assume naturalism, you are going to make a huge mistake. Furthermore, it is possible to have supernatural phenomena included in a hypothesis under the scientific method, as long as they leave evidence behind and are specific enough to make specific predictions. The danger of methodological naturalism comes when it is extended outside the functionality of the natural world and into historical sciences. Furthermore, there is still the risk of it degrading into metaphysical naturalism. Metaphysical naturalism, sometimes referred to as ontological naturalism or philosophical naturalism, is a worldview that posits that everything that exists is part of the natural world and can be explained through natural laws and scientific inquiry. It denies the existence of supernatural entities or forces, such as deities, spirits, or any phenomena that are beyond the scope of the physical universe. This philosophy underpins much of so-called modern scientific thought and has profound implications for how we understand reality, our place in it, and the nature of existence itself. Metaphysical naturalism is very dangerous in science because it destroys objectivity and possibilities within scientific inquiry. It leads to scientific dead ends and a naturalism of the gaps, where the answer is assumed to be a natural phenomenon regardless of how the evidence points. It also has a tendency, particularly in historical sciences, for problems with theories to be filled in with naturalistic just-so stories to patch problems with naturalistic models. The scientific establishment consists of all the institutions, publications, and other groups of the mainstream scientific community. Collectively, these groups dominate the officially accepted science around the world. While a lot of really good observational and functional science comes out of the system, it is also pushing a view of history and origins that, besides being inherently atheistic, has also become completely unscientific. This Big Bang to Man model of origins has become unscientific for two main reasons. The first is that it is being taught and promoted in such a manner that few trained scientists will question it, and those that do are easily ostracized. The second is that every aspect of this complete model has been patched so many times by untestable concepts and just-so stories that nothing could be discovered that would falsify it. This is the number one problem with the way the scientific community has developed. That is that there is the ability to hold back and prevent dissent from any theory that gains sufficient popularity within the dominant institutions and publications. Intelligent design provides an excellent example of this problem. There are two occasions where intelligent design has showed up in mainstream publications and the reaction was an uproar with a burn the heretics type of attitude. One editor was fired, the other only survived because the intelligent design reference turned out to be a translation error from Chinese to English. Politicalization of science is extremely dangerous because not only does it hinder scientific progress in an area, but it can also result in the creation of completely false claims being made under the auspices of science simply for political purposes. There are two reasons why scientists can be corrupted by politics. The first is that they agree with the political goals and therefore go along with creating fake science for the sake of political ends. The other is funding. When government funds a lot of science, it is possible for them to influence it in two ways. The first is the fact that those doing the research could be aware of losing funding if they come up with results not acceptable to the political class. The other is the political class choosing who gets government grants based on producing favorable results. For the record, it is just as wrong to claim that this always happens as it is to claim that it never happens. The big danger with the politicization of science is that it can lead to distrust of science in general and all the problems that can cause. One of the best examples of this is climate change. It first started being pushed by Vice President Al Gore while he was running for president. At the time it was referred to as global warming, but they then came to realize that climate change is a better term because it is not dependent upon the Earth actually getting warmer. That said, the idea is that if we did not stop using fossil fuels and go to electric cars and inefficient and unreliable power systems such as solar and windmills, that we were going to turn the Earth into a second Venus and we were all going to die. Not only have the original claims been greatly exaggerated, but the hypocrisy of those pushing it makes it very hard to believe. Here we have people driving around in gas-guzzling limousines demanding that we give up our automobiles to keep the Earth's temperature from rising maybe 1 or 2 degrees, and that's even assuming our activity is enough of an influence to do anything about it. The point is that this issue has become so politicized that it is impossible to know for sure how accurate the so-called science is. Because there is a political agenda behind the claims, it becomes extremely difficult to trust the science. In fact, that is one of the mantras of the global warming movement is trust the science. The problem is, it's not a problem of trusting the science, but not being sure about the science and not being sure whether or not we can trust the scientists who are pushing it. More and more when discussing science online, the tendency to see derogatory terms used against anyone who disagrees with a concept pushed as science by the scientific establishment is becoming more common. While there are times when the people receiving the derogatory term may deserve it, more often than not it is simply used as an excuse for dismissing what they are saying. For example, it is common to dismiss sources as unreliable, without providing any authority or basis for it, as an excuse for dismissing the content of an article or paper without even reading it. It is also quite common to dismiss somebody as being an idiot because they disagree with positions held by the scientific establishment. The three most commonly seen derogatory terms are anti-science, science denier, and pseudoscience. The first two are used against individuals while the third is used against areas of research. Now, this does not mean that every time these terms are used that they are not legitimate, but they are frequently used simply as ways of attacking individuals or ideas that a person using the term does not like. The use of such terminology really has no place within the realm of science, or any intellectual endeavor. One reason for this is that even if the terminology is being used properly, you will never convince somebody by using them. Imagine this from your side. If you were trying to have a discussion with someone and all they did was call you names, would they convince you that they were right? Well, of course not. Would they convince you that you are wrong by summarily dismissing any source material that you give them? Of course not. Ultimately, the point is that derogatory terminology has no place in scientific discussions. You shouldn't even use it when talking to flat earthers. Sure, many of them probably deserve it. After all, many of them are just trolls. However, if they honestly believe it, you are not going to convince them. If they are a troll, you are really only helping them. The use of derogatory terms is actually a type of fallacy known as an ad hominem. This is a fallacy where you attack the person, institution, and even entire lines of thought rather than arguing against them. Real anti-science is not merely skepticism of individual scientific findings or theories, it is a broader rejection of the scientific method and its reliability as a means of understanding the natural world. Such an ideology often dismisses evidence-based conclusions in favor of personal beliefs, political ideologies, or misinformation. The problem is that the term anti-science is frequently used in a much broader context. For example, someone may not reject the scientific method itself but being skeptical of a specific concept being promoted as science because of the politics involved. In other words, somebody is not anti-science just because in particular cases they reject something claimed as science for any of the reasons mentioned above, but only if it's a general pattern. One thing that the use of this label as a derogatory term misses when it comes to evidence is that the person may not be dismissing evidence, but seeing it from a different perspective than those who accept the concept being pushed. Ultimately, in most cases the term anti-science is not used for its legitimate meaning but simply has a derogatory term for someone who has an honest disagreement with something being pushed as science. This tendency, in part, results from those holding the establishment position being convinced that the only way of looking at the evidence is the establishment way, and that anybody who rejects that conclusion must be also rejecting evidence. They are often also confusing the evidence with its interpretation, such that in their mind rejection of the establishment interpretation of evidence is the same as rejection of evidence. If the term anti-science were only applied to people who actually reject science and the scientific method, then it would be legitimate. However, the problem is that more often than not it is used as a purely derogatory term, because somebody is questioning or even rejects a concept being pushed to science. Once again, you are not going to convince people by insulting them, but you might convince them with an honest discussion. Science denial is defined as the refusal to accept evidence-based conclusions that have been scrutinized and validated by the scientific community. This definition also includes the adoption of alternative explanations or outright rejection of scientific methodologies and findings. This derogatory term is more dangerous than that of anti-science. At least with the label anti-science you can always respond that you do accept the scientific method, but you simply have a problem in this one area. What this label does is make the scientific establishment not only the sole arbiters of what qualifies as scientifically acceptable concepts, but also you are being told that you have to accept their conclusions, even all your research says this is wrong. This is the case even if you look at all the evidence and either see it from a different perspective or see an institutionalized bias in the conclusions. This derogatory term literally implies that we are to accept whatever the scientific establishment decrees as scientific truth to be correct on blind faith in them, even if from your perspective the evidence does not say what they claim. The obvious dangers of this derogatory term is that it can hinder scientific development by not allowing new ideas to be considered. For example, a young scientist sees a problem with a generally accepted theory and proposes an alternative. If the response is that he's a science denier, and he is not allowed to present his idea for consideration out of this mentality, he can be pushed off into the background, while science continues to accept an erroneous theory because they refuse to consider an alternative. It is important for scientists to be free to challenge what is accepted by the scientific community. I had a problem with both quantum mechanics and relativity for years, even being trained as a physicist. I even considered alternative theories. However, I finally found a solution to my original problem that allowed me to accept both relativity and quantum mechanics, and I can defend them better in an online discussion than those who blindly accepted them from the beginning. This was because I had the freedom to question, search out alternatives, and then come to a conclusion on my own. The science denial label sets up the scientific establishment, essentially as a priesthood whose conclusions have to be accepted on blind faith. Real science needs to be open to criticism, even the criticism of those that may not be fully educated in what they are criticizing. Once you close that door, and tell people they must believe what we say, it is no longer objective science. The term pseudoscience, strictly speaking, means fake science. It is often used to attack concepts and areas of study rather than individuals. It is frequently used as a derogatory term for concepts that are claimed to be scientific by their proponents but are not accepted by the scientific establishment. Now, are there those who claim to be doing science and are not? Yes, there are a number of phony claims made, particularly under the category of medicine, that definitely fall under the category of fake science because they are deliberate fraud. The number one problem is that there is no official authority by which the label pseudoscience can be legitimately applied. There is no process of appeal that would allow the label to be removed once applied, because there is no authority to apply it or remove it. The application of the label is purely based on the opinions of those in the scientific establishment. If they have an erroneous view of a particular area of research, or have other problems with it, then the label of pseudoscience can be applied with no legitimate authority whatsoever. One of the main consequences of the false application of the term pseudoscience is that it allows establishment adherents to summarily dismiss any writings or evidence presented, from those to whom the label is applied, without even looking at it. This is because in the eyes of the scientific establishment they have already been deemed illegitimate and therefore not worth even looking at anything they have to say, sometimes even as a legitimate statement of what positions they actually hold. This is a purely derogatory term that should never be used unless you can demonstrate deliberate fraud. With no official way of applying the label and no official authority to do so, that it is nothing but a derogatory use by those in the scientific establishment that disagree with you. Within the scientific community it has the potential of keeping new ideas out, because they can simply be labeled pseudoscience and summarily dismissed. It makes it possible to claim that there is no evidence for something, when the truth is that there is simply no evidence that the scientific establishment will accept. This label makes it possible, because it allows an entire perspective on data to be summarily dismissed without even looking at it. They are then free to turn around and claim a lack of evidence to justify the pseudoscience label. Furthermore, it allows them to claim that the evidence only supports their position on the topic. Scientism is the belief that science is the ultimate or only valid way to gain knowledge and understand reality. It goes beyond valuing science as a powerful tool. It treats science as the exclusive path to truth, often dismissing other forms of inquiry like philosophy, ethics, or religion. Advocates of scientism may claim that if something can't be measured or tested scientifically, it's meaningless or irrelevant. Critics argue that this viewpoint is limiting, as it overlooks the complexity of human experience and the importance of subjective, moral, or spiritual understanding. While science excels at explaining the natural world, scientism assumes it can, or should, explain everything, which is a philosophical stance in itself, not a scientific one. This can lead to a kind of intellectual arrogance, where other disciplines are undervalued or ignored. Despite claims to the contrary by its adherents, scientism is actually a religious position with science at its center. Scientism is inherently atheistic for all practical purposes, worshipping science itself. You have many atheists who claim not to be religious, but they show a very religious attitude towards science. On the two occasions when Intelligent Design made it into a mainstream science publication, the result was for all practical purposes a religious frenzy, with a burn the heretics mentality. The simple fact is that at its heart scientism is the religion of science. This atheistic religion worships science. However, the irony is that they are not really interested in finding truth through science, they are interested in pushing their atheistic origins mythology as science. Within science, methodological naturalism tends to exclude anything supernatural. However, because methodological naturalism is not absolute, it leads to the possibility of supernatural explanations when there is a good reason for one. When you are trying to discover how the universe works on a regular basis, you clearly are not going to resort to supernatural explanations. However, if you are dealing with something that has the potential of being supernatural, you cannot exclude that possibility. This is because there is nothing in the scientific method that inherently excludes supernatural explanations. The only requirement is that they be specific enough to lead testable results. In other words, while simply concluding that an event was supernatural is not enough, concluding that a supernatural event occurred that would lead a particular result behind would fit the scientific method. Here is a good example. Let's say you had somebody who claimed that they could supernaturally heal people and will. You bring to them somebody who has already been diagnosed with a disease and let them do their thing. If indeed a supernatural healing occurred, the person would have been healed from that disease. To test this hypothesis, you take them to a doctor and have them examined. If they still have the original disease, then no supernatural healing took place. If the disease is gone, the hypothesis is confirmed and a supernatural healing would have taken place. Ultimately, the point is that a hypothesis can contain supernatural elements as long as they are specific enough to produce testable results. With those who claim that supernatural events cannot be falsified, are usually thinking is in terms of simply filling in a gap with a supernatural event. In other words, they see the supernatural as something that cannot be understood or leave any specific results behind. It fell over. You have a specific event with supernatural elements. It can be tested as long as what happened is specific enough to leave evidence. That is the real key to understanding how supernatural hypotheses can be included within science. There are multiple reasons why God and science do not contradict each other. First of all, science was developed under a Christian worldview. Second, from a biblical perspective, God is the creator and sustainer of the universe. The natural laws that exist because of him. Both the origin of life in biology, information nature of quantum physics point to the existence of a God that is outside of the spacetime of our universe. Furthermore, it is possible to construct hypotheses that include specific acts of God as part of their makeup, which lead to specific testable results. Such hypotheses are falsifiable because if true, they would produce specific results that would falsify the event if wrong. By the way, there have been such hypotheses and theories produced by creationists that had produced successfully tested results. Ultimately, God and science do not contradict each other. When science is allowed to, it complements the existence of God. It shows the order and functionality that God designed into the universe. You literally have to force God out of science in order for it to be any form of conflict. In conclusion, science is a very useful tool. However, there are dangers within the current establishment system of the scientific community. It ignores the difference between functional and historical sciences. Within historical sciences regarding the distant past, there is a tendency to patch up theories with just those stories. There is also a tendency to try to quell dissent to ridicule in other means. While there are areas when dealing with the present where it is extremely successful, assuming that level of success when dealing with the past, particularly the alleged distant past, it becomes way too easy for philosophical presuppositions to get in the way of actual science. Ultimately, science needs to be as democratized as possible to make it impossible for any central group to have any form of control. The use of derogatory terms and other ways of shutting down dissent demonstrate that there is a problem. The first thing to help these problems is to stop using derogatory terms and actually engage dissenters in honest discussion. If your side is correct, maybe you can convince them, if they think you are at least open-minded to their position.